All right, it's time to do the last section of chapter 6. So we're going to solve quadratic equations by factoring. So first of all, the definition, what is a quadratic equation? A quadratic equation is an equation of this form. In other words, a quadratic equation is an equation that has an x squared in it. Now, in that form, your a, b, and c are real numbers. That's what your R stands for, is real numbers. And your a cannot be 0. And if you think about it, why can't a be 0? Well, if a was 0, wouldn't this term disappear? So there would no longer be an x squared. So it would no longer be considered quadratic. So, to solve quadratic equations by factoring, we have to use what we call the zero factor property. And it's very simple, the zero factor property. It says, basically, if I have two things and I'm multiplying together and I'm getting 0 as an answer, then one of them has to be 0. That's the only way to get 0 when you're multiplying for an answer. One of them has to be 0. So one of the factors, these are the factors, would have to be considered 0. So how do I solve equations by factoring? Well, the nice thing is we're starting off fairly easy. Notice this one is already factored for us. So what you do now is you use that zero factor property. So if these two sets of parentheses are being multiplied and I'm getting 0 for an answer, that means either x minus 7 has to equal 0 or x plus 2 has to equal 0. One of them has to be 0. So you're going to find out that quadratic equations are going to have two answers. So if I solve each one of these individually, one of my answers was going to be 7. And this one I would just subtract 2. And my other answer is going to be -2. And there's my two solutions. Same thing happens in B. Again, notice it's already factored for us. So once it's factored, I'm going to take each of the factors and set them equal to 0. And I'm going to solve to get my two solutions. So for the first one, I would simply add 10 to both sides of my equal sign. So my first answer would be x equals 10. To get my second answer, I have to solve 3x plus 1 is equal to 0. So I'd subtract 1 from both sides. So 3x is going to equal -1. And when I divide then both sides by 3, my second answer is x equals -1/3. All right, let's keep going. So this one is a little bit different, but we do have it already factored. So we're going to take each one of our factors again and set it equal to 0. Well, if I take that first factor and set it equal to 0, I'm going to get my first solution. X is equal to 0. And then if I take my second factor of 4x minus 3 and set it equal to 0 and solve, I would have 4x is equal to 3 once I add 3 to both sides. And then dividing both sides by 4, I would get my second answer of 3/4. So, again, it's important that you know factoring. All right, so notice this one isn't factored, so we have to go ahead and factor this one. Well, we have had, sure enough, plenty of practice with this. So it's a trinomial, so I'm backwards foiling. So I'm going to get x and x. What two numbers multiply together to get -18 and add together to get -3? We're talking -6 and +3. So if I take each of those factors and set them equal to 0, here I'd add 6 to both sides. So my first solution is going to be 6. And I would subtract 3 from both sides. So my second solution is going to be -3. All right, a wrinkle. Look, before you factor, everything has to be set equal to 0. So I have to have everything alone on one side and have it set equal to 0. You cannot solve an equation by factoring if that is not true. So first thing I have to do is I have to add 9 to both sides of this equal sign. So I'm going to end up with 25x squared minus 30x plus 9 is equal to 0. So now it's time to factor. There is no GCF. Now, I'm going to remind you here, this immediately comes at me and screams perfect square. Remember the check. Take the square root of the first term, that's 5x. Take the square root of the last term, that's 3. Ignoring the sign, can I multiply those together and double it and get the middle term? Well, 5x times 3 is 15x. Double that, I do get 30x. So this factors as 5x minus 3 quantity squared is equal to 0. Now again, if you just start putting down 2 sets of parentheses and factoring in the old-fashioned way, that is absolutely fine. So now, if I take my one factor that I have and set it equal to 0, I'd add 3. I have to go over here, and I'd get 5x equals 3. And then dividing both sides by 5, I get an answer of 3/5. Now I know what you're thinking. You're thinking, but wait, she said that every quadratic equation would have 2 solutions. It does. We say that this has 2 solutions because there are 2 factors. The 2 solutions just happen to be identical twins. It does have 2 solutions. They just happen to be exactly the same. F, I'm trying to trick you. Don't let it happen. I'm trying to let you think, oh, it's already factored on this side, but it's not, because look, there is not a 0 over there. So what I have to do is I have to distribute through on that left-hand side. Now I have to set it equal to 0 by bringing the 5 over. So I'm going to subtract 5 from both sides of the equal sign. And it's not until I have that that I can go ahead and I can factor it. It's a trinomial, so I'm putting down 2 sets of parentheses. I've got an x and I have an x. So I need 2 numbers that multiply together to get -5, add together to get -4. Those 2 numbers will be -5 and +1. Taking each factor and setting it equal to 0 will give me my 2 solutions. So here I'd add 5 to both sides and I would get an answer of +5. Here I'd subtract 1 from both sides and I would get my second answer of x equals -1. All right, got a few more here. Let's look at G. I see a GCF. Hopefully you do as well. I'm going to take out a -5 as the greatest common factor, which is going to leave me with x squared minus 4x minus 12. When I divide that back in, that trinomial factors. If I go ahead and backwards FOIL, I'm going to get an x and an x. What can I multiply together to get -12 and add together to get -4? That's going to be -6 and +2. So now when we go ahead and when we take each factor and set it equal to 0, if I take this first factor and set it equal to 0, does that give me a solution? It doesn't. It doesn't even have a variable. So I go ahead and I take my second factor and set it equal to 0. And if I add 6 to both sides, I get a solution of x equals 6. And if I take my last factor and set it equal to 0, Solving by subtracting 2 from both sides, I get my second answer of -2. All right, let's keep going. Let's look at H. Well, notice it's already set equal to 0, so that's nice. There's no moving around, so it's just a matter of factoring. Does everybody notice that there is a GCF, a greatest common factor? I can factor out a 2x, which will leave me with x squared minus 9. This factors as a difference of squares. So remember, it factors into x plus 3 times x minus 3. So now going ahead and setting each one of the factors equal to 0. If I take this first factor of 2x and set it equal to 0, I'm going to get an answer. There's a variable, so when I divide both sides by 2, I get a solution of x equals 0. Taking my second factor of x plus 3 and setting it equal to 0 and subtracting 3 from both sides, I get an answer of -3. And finally, taking my last factor of x minus 3 equals 0 and adding 3 to both sides, I get an answer of x equals 3. Again, I know what you're thinking, but wait a minute, I have 3 answers for this problem. You do. That's because technically my original equation was not a quadratic equation. Notice that it has a degree of 3 and not of 2. So from my original equation, I ended up with 3 answers. All right, let's go on to I. Well, do you notice that this probably factors further? I don't think it's fully factored, even though there's an x plus 3 there. I think that second trinomial is going to factor further for us. So here we go. Let's go ahead and backwards FOIL. So I'm going to guess and check. Obviously, 3x squared will split up into 3x and x. The 7 can only be 7 and 1, but let's do 1 and 7. So when I FOIL these back out, am I going to be able to get a -20? Well, I get 3x squared. Outside, I get 21x. Inside, I get positive 1x. Am I going to get a -20 out of there? Absolutely. But what that means is the 21 has to be negative, so my negative is going to go there, and then this is going to have to be positive. So outside, I get -21x, and inside, I get positive 1x, which gives me my -20. So I take each factor and set it equal to 0. So if I take x plus 3 and set it equal to 0, subtracting 3 from both sides, I'm going to get a -3 as a solution. If I take 3x plus 1 and set it equal to 0, I'd first subtract 1 and then divide both sides by 3. So I get -1/3 as a solution. Fractions will happen. And then finally, if I take x minus 7 and set it equal to 0 and add 7 to both sides, I'm going to get x is equal to 7. Go ahead and try J on your own. Pause the video and then come back and watch as I do it. So when you did it, hopefully you said, aha, there's a GCF here of 3x that I can take out of everything. Nicely, it's already set equal to 0. You're welcome. So that's going to give me x squared minus 3x minus 4. Hopefully you then saw that that trinomial, which is left, is going to factor easily because it's just 1x squared. So what can I multiply together to get -4 and add together to get -3? So that's going to be -4 and positive 1. I'm looking at 3 answers for this one again, because if I take 3x and set it equal to 0, if I divide both sides by 3, I'm going to get 0 for an answer. Taking x minus 4 and setting it equal to 0. If I add 4 to both sides, I'm going to get x equals 4. And finally, taking x plus 1 and setting it equal to 0 and subtracting 1 from both sides, my final answer is x equals -1. Last problem of chapter 6. X-intercepts of the graph. If the graph is y equals ax squared plus bx plus c. So here's a little bit of vocab for you. First of all, this is a function. Why is it a function? Because it's a y equals. Whenever it's a y equals, it means that I can graph it. Okay, so now, how do I find x-intercepts and y-intercepts? So what x-intercepts mean? It means where the graph crosses the x-axis. That's what an intercept is. So an x-intercept is where the graph crosses the x-axis. What do points look like if they are on the x-axis? For example, this point could be, 1, 0. And this point could be, I'm just guessing, 3, 0. Any point on the x-axis will be of the form x, 0. The y-coordinate will be 0. So if I'm given a quadratic function and I'm asked to find the x-intercepts, I'm really looking for the following. What does x equal if y is equal to 0? So guess what I do in my equation? Wherever I see a y, I'm going to put a 0. And look at that equation. Doesn't it look like something we've been working with for the last 20 minutes? How am I going to solve that? Well, it's set equal to 0. It's a quadratic equation. I'm going to go ahead and I'm going to factor that right-hand side. Oh, I don't know. So 2x and 1x. Now I need to split up the 15. Well, it could be 3 and 5 or 5 and 3. What if we did a 3 here and a 5 here? Because then when I FOIL it back out, I'm going to get 2x squared. Outside I would get 10x. Inside I would get 3x. Can I get a -7 out of a 10 and a 3? I sure can, as long as the 10x is negative and the 3x is positive. How do I go ahead and finish solving? Well, I take each one of my factors and set it equal to 0. So I'm just solving that quadratic equation. So here I'd subtract 3. And I'd get 2 equals -3. 2x equals -3. And if I divide both sides of my equal sign by 2, I'm going to get -3/2 for one of my solutions. And adding 5 to both sides, I'm going to get x equals 5 for my second solution. So now, what did I just find? I found out that this graph crosses the x-axis at these 2 points. When you graph a quadratic, you end up with something called a parabola, which is like a cup, kind of like that. So notice it says sketch the graph. We're going to really just sketch it. We're not going to plug in any points or anything. 1, 2, 3, 4, 5. We know that it crosses the x-axis here. And -3/2 is actually -1.5, so we know it crosses the x-axis there. So when we go ahead and when we sketch a graph, we are literally just going to sketch a graph like that. That's all. It could go down a lot further. In fact, it probably does. I don't really care about that. It's a sketch. And there's the end of chapter 6.